Welcome to my channel Learning Electronic Circuits. Here you can learn more about different electronic circuits, its working principles and the construction techniques. What are resistors? The resistor is a commonly used component in electronic and electrical circuits. A resistor, when connected to a circuit, introduces an electrical resistance to it. The resistor is a passive component, which means it does not cause a power gain when the signal passes through it. A resistor works by limiting the flow of electrons in a circuit. As the resistor resists the flow of electrons, it results in the loss of electrical energy in the form of heat. Functions of a resistor. The important functions of a resistor are to 1. Reduce the current flow, 2. Drop voltage in a circuit, 3. Adjust signal levels, 4. Biasing the active components in a circuit, 5. Power dissipation, current bleeding or shunting, 6. Termination of transmission lines and impedance matching, 7. Low pass filter applications. Unit of resistance. The symbol for resistance is given below. The two commonly used resistor symbols are the IEC, International Electrotechnical Commission symbol, which is followed mostly in Europe, and IEEE, Institute of Electrical and Electronics Engineers, followed mostly in the US. The unit of resistance is the ohm, and the symbol used to represent an ohm is the omega sign. The characteristics of the resistor is determined by the Ohm's law, which is V is equal to I into R, where voltage V across the resistor is proportional to the current I and the resistance R. The ohm symbol is named after George Simon Ohm. The resistance of 1 ohm is the resistance between 2 points where 1 volt of potential difference will flow 1 ampere of current. Depending on the termination type, resistors are divided into through-hole type, surface mount type, special type. The through-hole resistor has leads at the axial ends of it attached with wire terminals, whereas others have leads coming out from the radial sides of the resistor, which are available in special packages. The SMD resistor is a smaller variety with very short leads on both ends. The resistors are also available embedded inside the IC packages. The fixed resistor values ranges from less than 1 ohm to more than 10 mega ohm. Power rating of the resistor. The power consumed by a resistor is power equal to V into I equal to I squared R equal to V squared by R watts. Here R is the resistance in ohms, V is the voltage in volts across the resistor, and I is the current in amps flowing through it. The power is converted into heat which must be dissipated by the resistor, and the failure to do so will cause the temperature to rise excessively that can damage the resistor. The power that is dissipated by the resistor must be within its power rating. The resistance of a resistor varies with voltage, temperature and time. Types of resistors. Depending on the functional nature of resistors, they are divided into one fixed resistor. These are resistors with fixed value. They have two leads at each end of the resistive material. The value of the resistor is not variable, although the resistance may vary with voltage, temperature and time. 2. Variable resistor. These are resistors whose values can be changed by adjusting the variable control on the resistance. A slider moves over the resistive material giving the resistor values. These resistors are further divided into A. Rheostat, B. Potentiometer, C. Trim pot. 3. Sensing resistor. These resistors have special resistor material whose resistance value varies with factors such as heat, light, humidity, pressure, chemical reaction, etc. Categories of resistor. Resistors are divided into 4 major categories. 1. Composition resistor, 2. Film type resistor, 3. Wire wound resistor, 4. Semiconductor resistor. We will describe these different types of resistors one by one. Composition resistors. These resistors are made from carbon dust or graphite. Carbon composition resistors are the most common type of composition resistors. The resistive element is made from carbon dust or graphite, and ceramic powder helps to bind them together. The ratio of carbon dust to the ceramic determines the resistive nature of the resistor. The mixture is molded into cylindrical shape and wire leads are attached to the ends. Carbon composition resistors are used in high frequency applications because of its low inductance, but it also produces noise and instability when hot. Film type resistor. These resistors are made from carbon film, metal oxide, etc. Carbon or metal films such as nickel or tin oxide are deposited onto an insulating ceramic substrate. The resistive value of the resistor is decided by increasing the thickness of the deposited film. A laser is used to cut a spiral groove type pattern in this film, which increases the resistive path. The metal film resistors have much better temperature stability, low noise, high frequency tolerance, good voltage rating, etc. The prefix which is given to denote metal film resistors are MFR. These resistors are used in high precision and high frequency applications. Wire-wound resistor. These resistors are made by winding resistive wires such as metal or alloy wire around an insulator such as ceramic former in the form of a helix. These resistors are able to carry higher currents, has good precision and high power rating. These are available in low ohmic values. The resistors are molded and pressed into a heatsink to dissipate the heat and assist cooling. Semiconductor resistor. These resistors are made from surface mount thin flow technology. These are mostly available in IC packages. Semiconductor substances are used to make this type of resistors. Semiconductor resistors are mostly utilized in ICs to miniaturize the size of the circuit. There are ICs which has the internal wiring done using semiconductor resistors, and the connections are provided through the pins of the IC chip. Here you can see different types of resistors. A resistor it's a component, electronic component that resists the flow of electrons, that it reduces the flow of current through it. And you can see different types of resistors here. We have smaller resistors and some larger, bigger ones like this. We have different types of resistors like this. And we also have some variable resistors, and these are all used for different purposes that has varying resistor values, that needs variable resistor values. So here you can see the carbon composition resistor. These are all carbon composition resistors. It's made of carbon and graphite. So we can see the resistor with different voltages. The different watt. We have the resistors here with different watt range. And this seems to be the smaller one. This is a smaller resistor. This is a carbon composition smaller watt resistor. And we have the bigger ones. These are higher power resistors, like higher watt. These can withstand higher power. These resistors withstand higher power. So this is a 5 watt resistor. This is also a 5 watt resistor. It's a 5 watt resistor. And this is a 10 watt resistor. This is somewhat smaller one. This is a carbon composition resistor. And here you can see some of the bigger ones. These are the bigger resistors. It carries higher power, and it is of a higher voltage rating. Here you can see a much bigger resistor, that is a 5 watt resistor. It's a 5 watt type of resistor. And similarly, this is also like a 5 watt resistor. This is a 5 watt resistor. This is a 5 watt. This is a 5 watt resistor. This is a 5 watt type of resistor. It can consume higher power, more power. So it has been made into a larger size. This is a 10 watt resistor. It's a 10 watt resistor. So it's the body is such a bigger one, and it's made of ceramic material and the other resistive material mixed together. So this is a higher power 10 watt resistor. These are all quarter watt metal film type of resistor. These are all quarter watt type of metal film type of resistors, circuits. So these are the quarter watt type of resistor. It's very comparatively smaller in size, and it's mostly used it's commonly used in most of the circuits. It's commonly used in most of the circuits. And you can see these are available as gross like this, and you can also buy it as a strip. These are resistor strips where you can buy it as a strip and take as needed. Here are also similar resistors. You can see the different. These are the strips of resistor. These are all quarter watt type of resistors. This is a more bigger resistor. It's a half watt resistor. This is a half watt type of resistor. It's slightly bigger than the quarter watt. Slightly more bigger. And these are the half watt resistor. These are half watt type of resistors. So you can carry more current than the quarter watt. You can carry more current. You can see this is also similarly half watt resistors. These are all half watt resistors. You can see this one is a 1 watt resistor. This is a 1 watt resistor. This can carry more current, and the power dissipation, everything is slightly bigger. It can carry more power. So this is the 1 watt resistor, and here you can see many larger ones. These are all 2 watt resistors. This can carry more power. It can dissipate more power, so it's made into bigger size. So these are all 2 watt type of resistors. 2 watt resistors. So these are all 2 watt resistors. You can see similarly here. These are wire wound resistors. These are wire wound resistors. There is a wire that is wound between the 2 terminals. So similarly, these are all different types of wire wound resistors. So wire wound resistors. These are all wire wound resistors. These are different types of wire wound resistors. These are all wire wound type of resistors. It can carry higher power, so for high power dissipation we'll be using more like these type of resistors. Here you can see the different types of variable resistors. These are also called as potentiometers. These are used as volume control in most of the audio and radio devices. This can be used to control the volume, the bass, treble and everything. So this is a potentiometer. It's a variable type of resistor. Here you can see the shaft. This is the shaft here, and there is a slider inside. These are the three terminals. There is a plate, a carbon plate that is extending from this terminal to this one in the entire length. So this is the central terminal where there will be a slider which slides through the entire length of the plate. By moving this shaft, you can change the position of the slider. It's made of carbon. There is a plate that runs through the disc inside this, and this plate has a carbon. There is a carbon coating on the plate, and when you slide this one, you can turn this around, and when the slider moves over the plate, and it just varies the resistance through that way, and you can adjust the potential between these 3 points. The potential difference can be adjusted or vary the resistance between these 3 points. So these are the wire wound variable resistors. It's a wire wound potentiometer. Similarly, this also has the 3 terminals here, and it also has wire that is wound around this drum, and this, when you turn this, there is a slider which moves along the length of the wire wound metal wire wound. It slides through the metallic wire wound resistor, and it just varies the resistor values between these 3 terminals. So it's a potentiometer that varies the resistance between these 3 resistor terminals. Similarly, this is another type of potentiometer. It's this is similar one, but it's connected directly to the board. So it's connected to a board. So this, when you turn this, you can change the resistance. You can vary the resistance between these 3 terminals. The center terminal that will be connected to this control, and this it slides over the entire range of the plate where you can vary the resistance. So this is a PCB mount variable resistance. This is a bigger, higher power, high voltage variable resistor. This contains a bigger element inside this drum, this variable resistor drum. It is much more bigger in size. The variable resistor that is placed inside this potentiometer, it's much more bigger in size, so it's a heavy type of potentiometer. This is a shaft, this is the shaft where you can control you can place the knob. Here you can see a different type of potentiometer. It's a ganged one, it's a dual potentiometer, dual port, or maybe stereo volume control. This can connect two channels and two sides. You can turn the volume, the resistor control. It's given into the two channels. This is one of the channel and this is another channel, so it's like a stereo potentiometer control. So all the other functionalities are the same. The difference is that it contains two in parallel, two variable resistance in parallel. So similarly here it's also the same. This can be used in stereo volume control, as a stereo volume control. This is another type of stereo volume control. This shaft, you can connect a knob on the shaft and turn this shaft around, and so that you can change the value of the resistor between these three terminals. Everywhere in all these resistors we see three terminals. These are three terminals, and it's been built in parallel to this, so you can control at the same time. A similar volume control. Here you can see different, and these are different types of variable resistor. These are presets or trim pots or preset resistor, or you can also call as trim pot. And this is a variable resistance where you need to have a fixed value. You cannot you can select a fixed resistor position. Similarly here there is a slider, there is a plate of carbon plate that is placed of the entire area in a circle, half circle, and there'll be a slider here, and by use of a screwdriver like this with a chisel head here, I can insert it into the hole in the slot here, and turn. You can insert this into the slot, and you can just turn the preset, the position of the slider. You can turn it like this and change the position of the slider. This is the slider notch. This is the notch where you will be able to know the position. So this is the preset output or trim pot resistors. These are different trim pot resistors. It has three terminals. These are the three terminals of this trim pot or preset resistors. This is similarly another type of trim pot where you can place this inside the notch here, and you can turn this around so that you can vary it. It goes through the entire length of this resistor, and it varies the resistance by screwing this up. When you screw this nail inside, you can screw this by inserting in the resistor value. So this is how we can do it in a preset like this. This is a type of trim pot, variable resistor trim pot. This can be mounted on a PCB, the terminals. You can use this. You can put this terminals inserted into a PCB and mount. These are different types of trim pots. So these are different types of trim pot where you'll be able to place it inside a circuit where you need a fixed a selectable resistor value, where you will be able to select the resistor value and set it there for the circuit to function properly. Here you can see another type of resistor. This is a photoresistor. This, when light falls on it, when the light is falling on it, it conducts. The resistor value is reduced when the light falls on it. These are different types of photoresistors. It has two terminals. These are having two terminals. So these are different types of photoresistors. This is another variety. These are photoresistors, where when the light falls on it, the resistance between these two terminals, it reduces. So thereby you can utilize it in photo sensitive devices, where when the light falls on the surface of this disc here, this is made of some photosensitive material. So when the light falls on this surface, it reduces the resistance value of this photoresistor, and it activates. It can activate as a sensor. It can act as a sensor and activate a circuit. So these are photoresistors. These are different types of photoresistors.